Hi everyone. I'm Osman Furkan Kar. I'm a graduate student at MITU Electrical and Electronics Engineering Department. And today I want to talk about the very basics and very fundamentals of my thesis study, that is structured signal processing, or also referred as signal processing on graphs. In my talk, I will be first examining the need of graph signal processing. Why do we need graph signal processing, and which problems do these toolset solve? Secondly, how do we represent a data that is irregularly structured? And finally, now that we know that why do we need graph signal processing and how do we represent a data that is irregularly structured, how do we process and analyze the signals defined on graphs, defined on these irregular structures, and in what ways these methods are analogous to our methods in classical signal processing. And that will be all. Thank you for your attention.
Okay, Osman, there are a number of problems with your talk. First of all, nice slides, nice fonts, etc. I like the view graphs, very simple, plain, except you're not facing the camera, Osman. Now you are. When you were talking, you didn't look at us. You need to arrange your setup before the talk so that you will look at the audience. Okay. Also, you need to have you need to think about the background behind you. Okay. So please position yourself next time you go for your talk. Position yourself so that you can look at the audience, and there is the background behind you is chosen such that there's going to be, people are going to feel at ease. Okay, at the moment I see a corner of a, there's something in the background in the corner, which should be okay, but I think you could have picked a better placement. Or you could always use a virtual background. Okay, when you pick if you decide to pick a virtual background, also try to make it look pleasant, maybe professional. It could be a scene from our department. It could be an office environment. The one that Kubra is using is very nice. So it's a scene from the campus. Okay, the other problem is, like many people before you, you didn't really write a text for your talk. So when you were talking, you were trying to come up with what you were going to say, and that caused a lot of filler sounds, and that slowed you down, and it completely couldn't grab our interest at all. I mean, you have to first know what you're going to talk about. You have to be able to say your outline by memory, because that has to be internally. You have to internally feel it. Okay, Osman. So either we can ask you to have a second go at your 1-minute talk, or you can, if you think you got it, you could just go ahead and prepare your 10-minute talk with these things in mind.
Hallederim sanırım hocam. Yani öğrendiğim gibi düşünüyorum artık. Daha
Okay.
dikkat edelim.
Guys, really, I mean, the purpose that we're spending this time, all of us, is we really want to improve our delivery skills. So basically, all you have to do is allocate some extra time to really think about what you're going to say in the talk. Write it down so that when you're talking, you don't have to search for words. Okay, who is next?
I will need more time.
I'm sure there are a few people who are ready to.
I can actually.
Oh, who?
Kemal.
Kemal, go ahead.
Yeah. Let me just share it. I believe you can see it now. Yep. So hello everyone. My name is Kemal Parlaktuna. I'm a master's student in our department, and I'm working with Murat Göl in the power systems area. So right now we are trying to develop a power system situational awareness tool for distribution systems. And I'm going to talk about that in my 10-minute presentation. I'm going to give you the outline right now. So my presentation will consist basically on 3 main topics. The fundamentals of the situational awareness tool, the implementation of it, which also consists of 3 parts, the state estimation, the forward-backward power flow, and the updating of the low voltage profile levels. And I will continue to talk about for the future work. And lastly, I want to mention the image on the right. So the distribution system, I want to clarify what distribution system is actually right now. And it is the orange part, the orange lines you see here. So our homes, the commercial loads or industrial loads all consist the distribution system, and we're working on that. So that's all. If you have any questions, I'll be happy to answer them. Thank you.
So Kemal,
Yeah.
you should have referred to the picture before you stated the outline.
Oh, okay.
Okay, you could have used this picture to increase our understanding of your problem. And you can say this is a grid or a distribution system, and I am very interested in creating a situational awareness tool for analyzing the system and monitoring the system. First, I will tell you about the fundamentals of this tool. Secondly, I'll tell you about its implementation in 3 stages: state estimation, forward, backward power flow, and updating of low voltage power profiles. And I will finish by discussing future work. And that's your talk. That's at the end of it.
Yeah.
Have a plan and use your visual aids to benefit, to help you convey to us what you're really talking about. Because when you said situational awareness tool, I'm coming from a place where I don't know about your research. For example, I don't understand what you mean by situational awareness. Situational awareness can be anything. It can be military. Okay, so if you talked about the picture first, that would have helped.
Okay. Yeah.
Incidentally, I know about Murat Göl's project.
No.
Currently, I'm trying to design a big platform project which this project will be a sub project.
Okay.
And so I'm interested I'm looking forward to your talk.
Okay.
So is this going to be like a SCADA that you will
Yeah, we'll use SCADA measurements
Mhm.
from substations, and like from medium voltage substations, we don't have any measurements in low voltage level. So using some load forecasting techniques, we'll try to run a forward backward power flow in low voltage level and try to update the voltage profiles of those customers. And by using the available measurements in medium voltage level and some pseudo measurements to maintain observability, we'll run a state estimation as well in the medium voltage level.
Currently, are you monitoring the PV
Yeah, there are
department?
Sorry?
The PV setup in our department on the roof of building C. Are you getting measurements from it?
No, we are actually using an open source data set right now.
Oh, I see. You're
Because
doing it sort of theoretically on.
We are doing it theoretically, but it's a project for actually Siemens. So we'll use real data, but we'll gather it from some distribution companies, some
Okay.
like energy source,
All right.
something. Yeah.
Okay, thank you, Kemal.
Yep.
Who is next?
Maybe I can do the presentation.
Please go ahead.
Okay. Can you see the screen? Hello?
I can see very well.
Okay. Hello, everyone. My name is Talha Çalış from Electrical and Electronics Engineering Department. I'm planning to make a thesis in the field of computational electromagnetics, and my thesis advisor is Professor Mustafa Kuzuoğlu. My thesis headings is efficient simulation method for finite planar periodic structures. In my presentation, firstly, I'm going to explain what is finite planar periodic structures and why we need to simulate this type of structures. After that, in second part, I'm going to explain classical computational methods like FEM method. In my thesis, I'm going to use a FEM-based further method, and in third part, I'm planning to make a suggested method for solving this type of structures, because in this type of structures there is a challenging situation. In final part, I'm going to make a summary, and we are going to talk about further ideas in this field. I'm planning to make a I'm planning to make a presentation not technical but informational and inspirational. Thank you for your attention.
So Talha and everyone, I sent you email yesterday. In my email, I asked specifically, please use an energetic voice.
Okay.
Okay. This is so important. You're not trying to tell us a bedtime story so we can fall asleep comfortably, right? You want to get our attention. Please use a voice that reflects that you are interested and excited about this topic. Secondly, many of you do this. I'm making a master's thesis. You don't make a master's thesis, you do a master's thesis. Okay. But other than that, I like your strange design. I don't know if you did this.
Yes, I saw this from templates and remake.
Okay. So please, when you come to deliver your 10-minute talk,
Okay.
use an energetic voice.
Okay.
And write a text for your talk. Use small sentences. When we speak, we tend to use shorter sentences than when we write. Okay.
Okay.
Great. Who's next?
Maybe I can.
Please go ahead, Furkan. Let's see the energy.
Can you see?
Yes.
Thank you. Hi everyone, I am Ali Furkan Aslan. I'm a master student in Middle East Technical University. I'm in the Department of Electric and Electronics Engineering. And today I'm going to talk about model fast analysis of small antennas. First, I'm going to talk about the fundamentals of computational electromagnetics. As we know, antenna is an electromagnetic structure, so we use electromagnetic tools that solve Maxwell's equation in a computational manner. After, I'm going to talk about the model analysis. Model analysis is a mathematical concept that uses mathematical analysis and the linear algebra. After I'm gonna talk the opportunities of the model analysis for some kind of antennas that is electrical small. Electrical small antennas have some unique structure that can be used for model analysis. Thank you for listening.
Thank you, Furkan. Not bad. Nice effort.
Thank you.
You know, we could use a little bit more, maybe a picture or something. I don't know what the picture at the cover slide meant. What is that?
It was a small antenna that is conformal and
Okay, so you can use that. You can use it to grab our attention. You can say, look, here's a small antenna. This is one of those, you know, antennas that I'm considering the analysis of. So far in the literature, this stuff doesn't exist, or you know, such analysis of such model antennas or whatever it is. It is still an open problem. And then now you got us interested. So we'll listen to your problem. Okay.
okay, okay.
Who is next?
Ben anlatabilirim
Mustafa
hocam.
Kılıç, what is this? Are you giving, what is this, a poem? Mustafa Kılıç. Maybe I can use this opportunity to...
Hocam, sorry, I couldn't understand.
Mustafa, we cannot see you. But we see something like a poem. Oh, hi, you're driving.
Yes.
Okay, drive safe, don't look into the camera.
Okay.
So, is Tutku Abonuzoğlu here today? No.
I'm here hocam. I'm
Oh,
here
I'm
hocam.
sorry, I'm sorry. Muhammed Akbulut. Yes, you're here. Büşra Akçada. No. Ali Furkan Aslan, he's here. Nuri Baran Ayana.
Here.
Talha is already here. Günercan Dündar. Nope. Oğuz Onur Güngör.
Here.
Mehmet Gürtekin. Yusuf Karabacakoğlu.
Here.
Yes, he's here. Yeah. Özkan Tuğberk is here. Mete Cankaya is here, right?
Yes.
Mustafa is here, driving. Fatih Serdar Sağlam. Nope. Furkan Şık is not here. Okay, good. Now, is there anyone else who's talking today? Except we know Muhammed will talk.
Ben de varım hocam.
Oh, Metecan, yes, and maybe also Tuğberk. Right, Tuğberk?
No, I actually last
Oh,
week.
yes, you spoke. Yes, yes. Okay, Metecan, would you like to go ahead?
Yes, I can. Hocam.
Mete, will you be able to adjust yourself so you can look at the camera while you're presenting? Oh, that's your virtual background?
Yes, kind of.
Mete, why is your virtual background disorganized?
I actually cannot disable
I see.
the virtual background. I tried, then it just stays that way.
Okay.
Hocam ben bir şey söyleyebilir miyim o sırada hemen?
Of course.
Hızlıca. Hocam Furkan Şık burada mı? Mikrofonu çalışmıyor sanırım. Bana mesaj attı da Hani az önce siz
okey.
sanırım yok yazdınız.
Evet, yok yazdım.
Ben de o yüzden
Ne
şey,
görüntüsü var ne mikrofonu kendisinin.
demin kamerası açıktı aslında.
Ha, öyle
Şu
mi?
an
Okey,
yok.
tamam. Ben düzeltiyorum.
Tamam hocam. Kusura bakmayın.
Okay, Furkan, we can see you.
Peki. Başlayayım mı hocam?
Yes, please.
Okay. Hello everyone, I am Mete Cankaya. I am a master student in our department. I am working with Gözde Akaz and I am doing my thesis on X-ray image segmentation. And today I am going to present you deep learning application and dental X-ray images. And I will talk about three things. First, I will introduce you the type of X-ray images in dentistry. You can see it on this image. This is a panoramic image which contains a lot of information. I will describe what are those information and how we can use them. Then I will pass to the current state of academy. So what has been done. Here you can see a segmented X-ray image, like you can see the root and other parts of the tooth has been segmented. Then I will pass to what is the future of this field, like this application will pass to industry or not, or what will happen basically. And thank you for your attention. Is there any question?
So thank you, Metecan. Let me repeat something from my email to you, all of you. Often you finish your talk saying, thank you for your attention. Or sometimes you even close by saying, this is the end of my talk. I've also done this before, and I don't recommend it. I mean, this is something that you end up doing when you have not thought of a more interesting closing statement. Okay, so I strongly urge you use that opportunity to be speaking to people to give them something meaningful, something that contains information, such as, so in my next talk, I will be telling you about the details of how we extract blah blah from images. You know, say them something specific about your own work rather than thank you for your attention. It's like, thank you for your attention. I've just tortured you. You know, I've taken your time, and you have just been patient. Don't do this. You know, for your own sake and for our sake, give us something. I mean, give us a feeling that we didn't spend this time in vain. Okay, who is next?
I can be next. Nuri Baranayana.
Please go ahead, Nuri.
All right, wait a second.
Nice background, Nuri.
Thank you. I believe all you can see my screen. Hello everyone, I am Nuri Baranayana. I'm a master's student at Middle East Technical University and Electrical and Electronics Engineering Department. And currently I am working on my master thesis with Professor Kemal Eblebicioğlu. Today I'm going to mention about subtopic of my research, which is sensor management by using multi-armed bandits. Firstly, I'm going to mention about sensor management by taking these three questions into the account. First, what is sensor management? And why do we use sensor management? And how can we use it in different areas? Second part is briefly touching my literature review. I'm going to explain research and applications about this field, sensor management, this topic. So the main algorithms that have been implemented on this problem to resolve sensor management. And finally, I'm going to explain multi-armed bandit in detail, how this algorithm has emerged and why it is an optimal algorithm to use. In this regard, I'm going to point out the significance of using multi-armed bandit in this on this problem. Thank you for your attention.
Thank you. Nice. So far, you're the energy champion of the day.
Thank you.
At least you were happy about. I mean, at least you were in a positive mood, and that affected me as the listener. Okay, so I enjoyed hearing about your topic. So that's good. By the way, multi-armed bandit is not an algorithm. It's a problem formulation. Maybe you should think about, this when you're preparing your talk. I will talk about the multi-armed bandit formulation and how it is applied to sensor management problems. Could say that, right? Because multi-armed bandit is a problem. It's not an algorithm. And now, I was once in an award ceremony a couple years ago in 2019, where we gave an award, Parlar Foundation Research Award, to someone whose main work is on multi-armed bandits. And they announced him saying, çok kollu haydut konusundaki çalışmaları için
Yeah, in Turkish.
verilmiştir. So basically, many people in the audience were very puzzled, obviously. So when we talk about this, when you say multi-armed bandit, it's always better.
By the way, it is not
hide.
bandits, right? It is not bandits, multi-armed bandit. Is it
Multi-armed
correct?
bandit.
All right.
Yeah. So a multi-armed bandit is one problem formulation. Basically, you can say, and you can say it, describe it very simply. It's a situation where you have to make a choice. And before you make a choice, you don't know which arm to choose. And as you choose arms, you learn more, etc. Something like that. So in fact, can we go back to your title slide?
Go back.
No, there's nothing on the title slide. Okay.
Yeah.
Maybe you could have a diagram here, or you could have like the multi-armed bandit original thing is a machine, right? It's a gambling machine with different arms. So it would help if you had a diagram, like or a picture. If I pull this arm, I make this much. If I pull this arm, I make that much with this probability. So it's a multi-armed bandit problem, and this problem has been applied to sensor management with success. So I'll talk to you about this today. Now,
For your information, I have tried to put a picture, but it didn't look good in outline part. There is no enough place. So I'm going to do better in element representation.
Whenever your problem is theoretic, if you try to find some picture that would make it concrete in people's minds, even if it is not exact, it helps. Okay. Thank you. So are we down to just one person remaining? Mohammed, maybe? Are you ready? Nice background.
I just fetched it from internet.
I thought it was, this is not the Metro library, is it? It's not, yeah.
Actually, what I did was I practically reproduced my slides, and in the meantime, the PowerPoint has crashed, and I've done it again. Well, I'm sorry for the inconvenience.
No, there's no inconvenience.
Okay, thank you.
On time.
Let me share my screen.
We're looking for energy, Mohammed.
Well, I'm also a little sick, so let's see how it helps. Hello, welcome. My name is Mohammed. I'm an MS student in Metro Electrical and Electronics Engineering.
Can you put your presentation in slideshow format?
Sorry, but couldn't you see my?
Maybe make it full screen or something.
Yes, I just done it. let me try it again.
Yes. Oh, anyway, yeah, now it works.
Okay. Hello and welcome. My name is Mohamed Akbulut. I'm an MS student in Middle East Technical University in Department of Electrical and Electronics Engineering. Today, I would like you to indulge with me in discussing what is the difference between H.265 and H.264, mainly under the main points of bitrate, method, and quality. What makes one and the other one better compared to other in terms of faster streaming, better compression, and what are the differences under method, namely interframe and interframe advancements, and what makes product produce a better visual experience, and how it enables higher resolutions. Thank you.
Thank you, Mohammed. Much better. I liked how you introduced it. You say, I would like you to indulge with me into understanding the differences of these two things, which made, kind of invited us into the topic. That was nice. Of course, today you have you're excused from energy because you said you're not feeling well. But hopefully next time when you give us your actual talk, you will be more energetic.
By the way, I couldn't also fetch a little images for those main points. That was actually
I guess so.
for my other presentation.
Okay, good. So I guess we're done, right, for today. Is there anyone else?
I left.
Oh, I'm sorry. Oh, please go ahead.
Hello, everybody. My name is Oğuz Onur Güngör. I'm a master's student in our department. I am currently working on quantum wave infrared photodetectors with Professor Cengiz Beşikçi. Today, I will talk about. Sorry. Okay, let me start again. Hello, everybody. My name is Oğuz Onur Güngör. I am a master's student in our department. I am currently working on quantum wave photodetectors with Professor Cengiz Beşikçi. Today, I will talk about the outline of my presentation. My presentation topic will be infrared photodetectors and imagers. In my presentation, first I will talk about infrared radiation and what is it, and then I will introduce you to infrared photodetectors and their types. And lastly, I will talk about current challenges of different photodetectors in the field. Hopefully, in that you will understand how we can see at night and how we can see, know the temperature of the objects around us without touching them. That's all. Thank you for your attention.
Oğuz, how do you rate your own talk?
I don't know.
Well, in terms of, I think you were working on this because it's a very fascinating field. There is both scientific depth and applications, and you could do a much better job at allowing us to feel that. Okay, so I recommend that when you deliver your 10-minute talk, be more excited about the topic and convey this excitement to us. I mean, photo detectors, you said we can send something without touching it. Is that the only application? I don't know. I mean, maybe you could use pictures here of there are millions of applications.
I want to use, but there is some copyright and confidentiality issues. So I can.
Well, sometimes you can use pictures that you don't own by giving the proper credit in your slide, or you could find a picture that is not protected under copyright, or you can draw something. I don't know. It doesn't mean you cannot ever use a picture. Okay, so anybody else today?
Ma'am, can I ask which Furkan presented today? I see two Furkans.
So this Furkan, what's his last name? The other Furkan Şık did not present today. I don't see the last name of the. What's your last name, Furkan?
Thank you.
I will also post this on YouTube. So the video, I'll make it unlisted so that people won't be able to find this online. We don't want to humiliate ourselves, right? So, but if you have a problem of this being on YouTube, just let me know. I mean, it's just convenient because I cannot upload the video on OptiClass. It's too big. Okay, so far so good.
Sorry, I think I misread. Furkan